Everyone for joining today. Today I'm going to be talking about asynchronous programming and JavaScript and basically talking about the benefits of why you would even want to use asynchronous programming, how that differs from synchronous, and how it can just help make your applications more performant. This is the agenda of what I'll be covering today, just starting with a quick welcome, going over an asynchronous JavaScript overview, then getting into the three types of asynchronous programming that you can do with callbacks, promises, async await, and I'll close with next steps, and then there should be plenty of time for questions as well. And also just feel free to ask questions throughout and continue to be active on the chat. I have two of my teammates on the line, Christopher and Sarah, so they're able to answer any questions and chat with you during the chat. I'll also do my best just to try to monitor it. But yeah, so that's pretty much everything. My name is Megan Lewis, so I am a program manager at Microsoft, and I'm on the Reactor content team. I focus primarily on developing content, which focused originally on in-person content, but we have been trying out our new kind of digital content strategy for the past couple weeks now. So we've been running some of these live streams, which maybe you've tuned in before. And we're going to continue running live streams and continue trying to deliver great content on behalf of the Microsoft Reactors. I did leave my contact information there below, so feel free to reach out if you want to talk about anything that was discussed today, if you want to just get in touch and maybe have suggestions for future content that you'd like to see, either online on a live Twitch stream or maybe in person, let me know. I will briefly talk about the Microsoft Reactors. So Reactors are community spaces that we have across the world. We have 11 different locations where we provide free skill training in the form of different workshops, tech talks. We host meetups. We have a combination of first-party programming that Microsoft puts on ourselves, and then we also allow third-party programming for individuals and communities to kind of put on events at Reactors. So if you want to learn more about Reactors, feel free to go ahead and visit the website below so you can learn a little bit more, see any upcoming events, learn how to host your own events in the future. And you can also follow us on our Twitter at MSFT Reactor, and we're very active on Twitter, so we'd love to hear from you there. So now let's get into the content. So I want to talk about what asynchronous JavaScript even is and why we use it. But I think before doing that, it's important to first highlight what synchronous JavaScript is. And so some of you might be familiar with synchronous JavaScript and kind of what that is. But basically, in its most basic form, JavaScript is synchronous. It runs on a single thread. It's blocking, and which basically that means only one operation can happen at a time. So with synchronous JavaScript, operations happen sequentially. So you can think of it as waiting in the line, for example. So just a line is going to operate on that first in, first out basis. So basically you have to wait for other people to complete their transactions before you can move ahead in the line. And it's blocking, which means that the next step is blocked until the current step is finished. So kind of that same concept that I just described as waiting in a line. With asynchronous, on the other hand, statements can be executed in parallel. And this means that it's non-blocking. So basically the application can continue to handle user input and do other things while this other operation is running at the same time. So when we think about blocking, we can kind of phrase it as a way of stopping execution on the main thread. So I mentioned before that JavaScript is single-threaded. So typically what that means with synchronous is that we're running task A, task B, task C on that main thread. With asynchronous, we can start to explore using workers. So workers can run off of the main thread, and they're great for running some of those long running operations that might happen in an application. So the way that you can think about a worker running in addition to the main thread is that the main thread can go from task A to task B, and maybe the worker is off on task C. So it can be running a different thing at the same time without kind of preventing blocking of the main thread and kind of keeping those shorter sequential tasks to just running on that main thread. So you can see that asynchronous is useful for managing long-running operations, which would otherwise stop execution. So just a few examples of what asynchronous JavaScript might look like is for server calls. So server calls, typically you're going to be sending a request and getting a response back from a server. So some longer running server calls might just be when you're calling an external API. Maybe you're doing something on your application like uploading data or images, you're parsing documents, you're doing something that's going to be a little bit more time extensive. There's also some database calls. So with database, you're doing things like connecting to a database, you're reading and you're writing, and you're kind of doing something with that information. So database access can also be a long-running operation. You might want to move to a worker. And then there's just additional complex algorithms that an application can have. So typically, the more operations that an algorithm has, the longer it's going to take to execute. So it can be helpful to kind of send those off to run on a separate worker. So for asynchronous JavaScript, pretty much I think these are the main points that you have to remember, is that the statements can be executed at the same time, it's non-blocking, and you want to use asynchronous JavaScript for long-running applications. So in more modern day applications, we see a lot more activity happening on applications. I think the first time, just thinking of an example, the first time that I used asynchronous JavaScript was probably about 5 years ago when I was working at a company that built a recruiting platform. So in that platform, we started out by using synchronous JavaScript. I think that was easy to get started. It was fine, especially for doing things like collecting information from people. So they're starting their profile with this recruiting platform and just filling out basic information. As time went on and our application became a little bit more advanced, we had to do things like upload and parse resumes or perform batch operations on a bunch of users. So maybe we're changing a bunch of candidates to a specific stage in the job application process. So it became important to introduce asynchronous JavaScript. So basically, you'll see that as applications evolve and become more complex, it is definitely beneficial to use asynchronous JavaScript because that's just going to be a much more performant way to kind of have different processes running at the same time. So for example, thinking about this recruiting platform, if someone was uploading a resume and that needed to be parsed, like we can show a message, okay, this is uploading and it's in progress, but you can go ahead and do other operations at the same time. And you don't have to just wait for this to be finished. When it's done, we'll let you know. So that's just a quick example of the differences kind of between asynchronous and synchronous and why you would want to use synchronous, for example. Hope that makes sense. All right, so now I was just checking the chat window. So now I'm going to move over and walk through some examples. Okay, so here I am using CodePen, so codepen.io, and you can kind of follow along if you want. I can share this URL out. But CodePen is just a really nice way to write HTML, CSS, and JavaScript code and just execute it on the fly, basically. So this is a nice alternative to using an editor that you might have downloaded on your desktop, just a quick and easy way to write code. So I think this will be the best way today to show examples. If you can see over here on the right-hand side, I just have some basic HTML kind of describing some of the high-level concepts that I'm going to be talking through. So let's go ahead and start by looking at callbacks. So callbacks are functions that are specified as arguments when calling a function which will start executing code in the background. So let me just kind of put that in more simple terms. Looking at that set timeout function, for example, set timeout I think is one of the kind of classic asynchronous operations that we have. So set timeout, basically what you're doing is you're setting a delay that you want your application to hold for. So it's just going to pause. And after that delay that we specify in milliseconds, so that's 5,000 milliseconds, which means 5 seconds. After that time, we can go ahead and execute that function there. So this is a really nice way to just see what a simple callback looks like in action. So basically, we pass a function as a parameter to be executed once that delay or other event is met. So basically you're passing in some kind of condition to any function. It can be a time, it can be waiting for some action to happen, like a page to load or a certain event to occur. And then what you want to do is kick off a function to happen after that. So you're kind of just defining in this function what you want to happen next. So I want to move kind of away from seeing it over in the HTML just to write this example out. So just so we can get a sense of how this would actually execute in real time. So I'm just going to basically do the same thing over here. And inside of that, I'll say console.log. And let's just say this is async. And then I'm going to specify that timeout of 5 seconds. So then when I save this, and I'm going to go ahead and run it, what will happen is after 5 seconds, I will see the console log this async text. So that should be pretty straightforward. I'm going to add one more thing after this, another console.log. And just say something like sync. And now I want to save this and run it again. And now we can see what happens there. So I'm going to wait for that. But you see that after 5 seconds, the async came after the sync. So what happened when this was executing was we called the set timeout function. And while that was waiting for 5 seconds, we moved on to execute this console.log. So even though this one was kicked off first, it was just not completed first. So we actually just see the results of that second statement first. So hopefully this is pretty straightforward. Next, I want to move on to another example that I think will help illustrate callbacks pretty well. So I'm just going to comment this out. I'm going to add a bunch of examples in here, and I don't want it to get too cluttered, but it might help to come back to later when I share out this link. So the next thing that I want to look at is an example using XML HTTP request, which is kind of a mouthful, so we call it XHR for short. And what that allows us to do is to interact with servers. So we can retrieve data from a provided URL and then do something with that data and the response that we get back. Despite its name, XML HTTP request, this object does not just deal with XML data. We can use any type of data. And as you see in the example that I'm going to do, we're actually going to be working with JSON data. So now let's look at an example of using XHR in action. So I'm going to define a new variable called XHR using that let command. And then I want to create a new XML HTTP object. So we'll type that out. Add a semicolon at the end. And next what I want to do is describe the callback for this function, and I want to look for a certain event to happen. So what I can do here is say xhr.add event listener. And in that function, I'm going to provide a couple parameters. So first, I'm going to be providing this load parameter. And that is basically the event that we're listening for to happen. There's other events that we could listen for using XHR. We could look for events that are in progress. We can use for events that have been aborted or failed or something else. So this is kind of just the simple event that I'm going to look for. I'm going to look for this page to load and wait for this action to be completed before I do what's next. And that is going to be to call this function. And with that function, what I want to do is to be able to get what's loaded on that page and convert it into a JSON object. So I'm going to say let JSON, defining a new JSON variable, and say JSON.parse. And this dot response text. And add a semicolon at the end of that. And then after this, now that I have this JSON in a variable, I just want to add a simple console.log statement to see the contents of that JSON. So I'll specify specifically the json.url and add a semicolon at the end of that. And then I'm going to close out this function. And down below, there are a couple more things that I want to do. So far, I've just added this event listener, which has my callback. Now I need to actually open the connection so that I could be able to send requests. So I'm going to specify to send a GET request to a specific URL, https://http://ben.org/get. And this URL is basically kind of just a simple HTTP request and response service. I can show what that looks like. So we're looking specifically at the GET endpoint over here. And you can kind of see what it responds with, some arguments, which there are none, different headers, the origin IP, as well as the URL. If I just look at the root of this page, I can kind of see all of the different actions that I could use to send different requests and send along data. So this can be a good thing to use just while testing. I recommend it. So I'm just going to continue to kind of use this throughout, but just so you know what's on that web page that I'm actually using, I wanted to show that. So let me add a semicolon to the end of this statement. And then the last thing that I want to do is to send that request. So I'm going to open the connection, send the request, and then I'm waiting for this event to happen, this load event. And I'm going to get the JSON response from that page. And then once that happens, this should print out the console line. So let me go ahead and clear the console. I want to save, and then I want to run this. You can see the page was reloaded. And I expected to see a response by now, so it's possible that I did something wrong. So let me look at debugging this, because yeah, there's nothing in the console. So I'm going to retrace my steps a little bit just so I know that I'm doing everything right. So I have this new XHR variable, and I am creating a new XML HTTP request object. I think that's all spelled right. I am adding an event listener looking for this load event. Then I'm passing in my callback function. And then what I want to do is parse the JSON. And then I want to print a message to indicate that that was successful. And I'm going to open the request looking for, okay, so open the request looking for this URL, and then send it. Okay. Awesome. I think I'm getting some help here. I do see that this was misspelled. So this is kind of what happens when you're doing live coding, is that you tend to misspell things. So I'm going to save that. I'm also getting a request to make the text bigger. Hopefully that's better. Oh, I see. Does that look better, y'all? Okay. Hopefully that's better. So now I'm going to save again, and I'm going to run. And now that I have fixed all my typos, you can see what happens here. So I get this console.log message to say that we successfully called this specific URL here. So hopefully that all makes sense. I'm going to look at the chat window that I've been missing for a little while. I would have caught that error sooner. Thanks, y'all. Okay, awesome. So hopefully that explains a little bit about callbacks. Are there any questions about callbacks that I can answer, or Sarah or Christopher can answer in the chat? All right, I don't think there are. So in that case, I'm going to move on to talking about promises. So promises, at a high level, they're going to execute additional code after the async function is complete. So basically, this kind of acts as an IOU, you could say. So it's just going to send off this promise to go say, hey, do this task and get back to me when you're done. An interesting thing about promises is we don't know exactly when we're going to get a response back or what that response is going to be, but we know we're eventually going to have either a success or a fail that we're going to get back as a response. So when a promise is called, it returns information about the operation and its state and the result. So there are three different states that a promise can have. It can be inactive, or sorry, it can be pending, which is kind of the initial state where nothing has happened yet. It can be fulfilled, which indicates success, or it can be rejected, which indicates failure. So those are the three different states of a promise. And the promise will also have a result. So results, you will either have a value, so again, if that state is fulfilled, or you will have an error if that state is rejected. So those are kind of the high level points. You can see the syntax here that I listed just in the pseudocode example there. And basically what's happening is that when a promise is called, it is kind of creating, when a promise is called, it is creating kind of this chain of actions to happen after. So I'm saying promise.then. So I'm waiting for, I'm going to call this then action. I'm going to wait for a result to come back to me. And then I have to kind of determine what to do when I get that result back. So I'm going to have some data returned. I can kind of look through the data, understand what to do next. And then I might want to run some additional code blocks. So another then statement, for example. So then is basically just what's going to be executed upon a successful promise. There's also other code blocks that we can use, like catch, which is going to be executed upon an error result, or finally, which you can use to just indicate that the promise is settled and that there's no other actions that you need to do. So promises were introduced in ES6. So this was, I think, still about 5 years ago. And I think they're essentially callbacks under the hood, but it kind of allows us to have a different syntax and format of the way that we are structuring our asynchronous code and the way that we're using these code blocks, these then and catch statements to kind of determine what to do next and how to handle or resolve this promise. So I'm just checking the chat window. Okay, so now let's look into an example of using a promise. And I'm going to come over here to my JavaScript window. But before I do that, let me just go ahead and comment out this last example. And now let's start looking at an example of using a promise. So here I'm going to use something called fetch. So the fetch API just provides us another way to interact with servers. It's pretty similar to XHR. It's just kind of the more modern and new version. And I think it's really nice to use specifically with promises. So with fetch, I'm going to just go ahead and call, I'm going to go ahead and call that fetch API. And what I just pass in to the fetch API is a URL parameter. So I'm going to use the same URL that we had used up above. And then what I want to do is to add a then statement after this. And what I'm going to be looking for is a response from this fetch call. And in the body of this function, I want to say return response.json. Let me make sure I'm spelling all my responses right. I think that looks good so far. And then what I want to do after that is add another then to say I have a new function and I'm entering this JSON parameter. And what I can do with that is say console.log. Basically, I'm going to do the same thing that I did up here. So after I have the JSON, I want to do something to parse it, and I'm going to be looking for a specific part of that JSON that I want to get back. So I can say successfully called json.url. And then after that, I'm going to just show what it looks like to add a catch statement to look out for exceptions that might happen when running this promise. Not sure why that keeps happening. So then I'm going to pass in a function that's going to have a exception as a parameter. I'm just going to use that syntax. And then I can say console.log. And I'm just going to say something went wrong. And similar to the statement above, I can say something like, let's just go ahead and log that exception. All right, so let me add a semicolon at the end of this just to close out this promise. And then I'm going to go ahead and save. And now let's see what happens when I run this. So after just a few seconds, we get back that it has successfully called this URL endpoint. I can show what happens kind of when we look at the error case for this. So say I'm fetching a URL that's not quite correct, or yeah, I can do that. So basically from that fetch URL, what's happening is my promise isn't really sure how to get the exact response that I'm looking for. It probably doesn't have this JSON URL to be returned, so it's basically just letting me know that something went wrong, and it prints out an exception. It's debatable how helpful that exception actually is, but this could just be a really nice way to be able to catch problems that do come up while you're executing a promise. And it just also illustrates how you can chain these different then blocks. And you can also add on a catch, or even after that, a finally, just to say, okay, I'm done with this promise, and basically this has been resolved, so it's good to go. Okay. Are there any questions about that? I'll pause and see if there are, but I'm also interested to know from y'all, what do you think the main differences are, kind of seeing between how a promise is executed and looking at that syntax as compared with a callback? What would you say are some of the key differences there? All right, so I am seeing a couple different answers. Promises are cleaner. Okay. The parameter passed into the function. Oh, that's from Christopher. Okay, so it's a little hard for me to follow along in the chat. There's a lot of messages. So thanks again, Christopher and Sarah, for getting those. But yeah, so basically the syntax is cleaner. I think it's a little bit easier to represent promises and to do this kind of clean chaining by adding multiple then statements or catches. Also, just by adding catches, it's an easier way to do error handling than was allowed with callbacks. Callbacks can be a little bit more complicated, and you just have to add a lot more code to kind of gracefully handle error catching. And I think promises are just generally a little bit more easier to read and to write, at least I would say so. And I mentioned before, this is kind of the more modern way to actually write asynchronous programs. So this was introduced later, and there are specific kind of libraries and functions that work really nicely with promises. So promises are just a little bit of an updated convention that you might use when asynchronously programming. All right, so now I'm going to move on to look at yet another example and kind of move forward into the async await. Okay, so I've cleared that out. We lost the HTML, but that's okay. It will probably be back soon. So async await kind of provide a way to streamline asynchronous programming that you might say. So the way that you write async await functions, it's very similar. It looks very similar to how you might write synchronous functions, but there are a couple key differences. So first, and it would be helpful to have that HTML page back, but that's fine, it'll come back. So first there's the async keyword. So you put that at the beginning of your function declaration, and that async keyword is just going to say that this function will be executed asynchronously. And then there is the await keyword, and that is used inside of the function to indicate that we need to wait for the return of a promise, and kind of pausing until that promise is returned or that statement is executed. So async await is kind of just more of a nicer syntax to use for handling asynchronous code. And I guess one interesting thing to note about async await is that you have to use await calls inside of an async function. So those two always go hand in hand, which is why it's called async await. In that with async await and just writing functions using this convention, you, like I said, they can be very similar to synchronous execution. So I can add in other parts of JavaScript that are written synchronously. There's also a nice way to do error handling. So like I can use try and catch, for example, and I'll show that when I write an example over here. But that's just a nice way to handle error catching and kind of provide a more clean syntax that is easy to get adjusted to if you're already familiar with programming in JavaScript synchronously. All right, so now let me run through an example. So here I can say async function run demo. So here I'm just going to define a new asynchronous function, and I'm going to add a try catch block in here. And in this try block, I'm basically going to do the same thing that I did in this function above with the promises, but I'm just going to use this async await convention. So here I can say let response is equal to await, and I'm going to call that same old fetch API and pass in a URL here. All right. And then after that, I'm going to say let JSON. So I'm just defining a new JSON variable, and I'm going to be getting the JSON response back from that. So I'm going to call another await and say response.json. And then after that, I can go ahead and print that same message that I have been seeing before. And let's just go ahead and say called. And that is the contents for my try block. Next, what I'm going to do is say catch. And what I'm going to want to do in here is to catch any exceptions that might happen. So I can say console.log, and I'm going to say error. So basically something went wrong. Again, the same thing. This is doing the same thing that I did in the example above, just using async await. So here I can just write out that exception if something went wrong. And then the next thing that I would need to do is just to go ahead and call this function run demo. And I'm going to go ahead and save this. Quickly look through to confirm that I spelled everything correct. I think it looks good. And then I can go ahead and run this. And we can see in the console that we have called that URL again. So this call was successful. I can do the same thing to simulate exceptions from happening just to show you that. But otherwise, this is pretty similar to how a synchronous function might look. The big things are adding this async keyword, and then within this function, adding the await. So just to provide a little bit more detail on what's happening in each of these steps. So these steps are actually being run sequentially. So we can say that we are waiting for this fetch API to be run and then getting a response from that, because we need to use the response next to get the JSON object and return that to our JSON variable. So we can use multiple awaits, pretty much as many as we want to. I guess kind of a caveat there is, as we are adding more awaits, this is going to kind of add more sequential execution to our program. So that's just something to keep in mind, is how you're actually writing these async functions. But overall, it's a much cleaner and kind of streamlined way, like I mentioned, to actually use asynchronous programming. This was introduced in ES8, so just a few years ago now. And I would say it's definitely the more modern way, just by providing kind of this more cleaner syntax, but under the hood, it's essentially doing the same thing as what's happening when a promise is being executed. Can anyone else identify any other differences of between async await and promises, and maybe why you would want to use one over the other, in addition to the things that I've mentioned? So in addition to the cleaner syntax, what might be some other benefits? All right, just checking the chat. So I think, yeah, maybe I have mentioned a lot of benefits. And so in addition to the clean syntax, it is a nice way to handle errors. That might be more in line with the way that you're used to handling the errors, because this is kind of the same kind of synchronous style that we're using to write our function. So it's really easy, maybe not really easy, but if you already know synchronous JavaScript, I think this could be a great way to explore writing asynchronous JavaScript, starting with async await and kind of being able to change the syntax of your regular synchronous functions into asynchronous. And maybe this is also a great way to be able to kind of compare how the execution might be and what the response would be using asynchronous or async await as opposed to just writing an old synchronous function. Cool. So that is basically the few examples that I have through today. So I believe, did I share the code pin URL in there? I will share the code pin URL, and I'm also just going to stick around and kind of make sure that we're answering all the questions. I do want to point out a few more things. So I'll open this page up. And here, that link, so aka.ms/ sorry, I don't know where that went, aka.ms/async.js. So this is just some resources that we have over here to kind of explain some of those high-level principles about asynchronous programming. It has more information about callbacks, promises, async await. You can find code pin URLs in here, and then you can also find a list of resources at the bottom, so you can see more information about asynchronous, about promises, callbacks, async await. And then that last link that I have there is for the Web Fundamentals 2 course that we have, so it covers more about JavaScript in addition to HTML and CSS, so it can help to kind of reinforce and bring all this information back together. All right, so I'm just going to pause now. Yes, can I share the GitHub link? Definitely. And then let me also just go ahead and share the code pen link again. And I would recommend, just since I went over these examples kind of quickly and you're not necessarily seeing them in a very real world application, it is important for you to take some time to walk through examples on your own and to kind of see the differences between each of these three different types of asynchronous execution, and to get a better understanding of when you might want to use one over the other. So check out the resources that I listed there. Feel free to continue to chat with us. And I think that's all that I have for today. We will be uploading this video to our Reactor YouTube channel. So you can check out this as well as the other videos that we've uploaded from live streams in the past. And we'll be back next Tuesday for another live stream. Thanks everyone for tuning in, and see you next week.